All right, so we're going to continue on with 1.6 today. Then tomorrow we'll hit up 1.7. And then we'll review on Friday for your test, which is going to be on Monday. So we're going to talk inequalities today. But before we talk inequalities, let's talk about equalities. So if I ask you this question, what in the world is equal to 7? The only thing that's equal to 7 is 7. That's it. Equalities is an exact science. Right? 7 is equal to 7, and nothing else is equal to 7. Negative 7 is not equal to 7. Right? The only thing that's equal to 7 is 7. Okay? So that's equalities, exact. Inequalities, which we're going to deal with today, is more of a broad range thing. So give me an example of something in the world that's not equal to 7.
-7.
-7. What else? Give me another one. 6. Give me another one. 0. Give me another one. 1. Give me another one. Somebody else. 2. 13. Pi. Square root of 8. Okay? All those not equal to 7, right? Okay? And could we go on like that forever and ever and ever? Okay? We could go on like that for a long time. Okay? Today, what we're going to learn is we're going to learn how to say things not equal to 7 in a nice, short, concise way. And then we're going to be able to graphically represent that in a nice, clear, visual way. Okay? Okay? So that's what we're going to do today. So, first thing we have to talk about is we have to talk about the inequalities that are out there. The first inequality is less than. The next one is greater than. Less than or equal to adds a bar underneath. Greater than or equal to adds a bar underneath. Okay. And then not equal to is equals with a line through it. Okay. Now, way back when you were learning about inequalities, your math teacher probably talked to you about the alligator eats the bigger tern. Okay? Right? For me, I call less than and I call greater than. I call those my alligators. Because alligators are smaller. Okay? Crocodiles are bigger. Okay? So I call the other two crocodiles. Okay? So alligators and crocodiles, they eat the bigger tern. Okay? Right? So that still plays even today. Okay? Now, when I go to graph an inequality, we are going to graph them on a number line. Okay? Now, your number line does not have to include a ton of numbers. Really, I only care about the 1 or 2 numbers that are in that particular problem. Okay? So those are the only numbers that really need to go on your number line. Okay? But there are 2 parts to the actual graph. The first part is the dot. Okay? So the dot needs to either go on or above the number line, and it needs to be clear. Okay? I need to know if it's a filled-in dot or a closed dot. dot or an open dot. Okay? And I don't need to be straining my eyes to see it. Okay? It should be clear as the sun in the sky on a non-cloudy day. Okay? You should be able to just visually look at it. Boom, there it is. Okay? The second part is an arrow. And the arrow needs to be above the line. No matter what, the arrow is above the line. The arrow is not on the line. Okay? So let me give you a couple of different scenarios going on here. So my first example is going to be x is less than 4. Okay? On a number line, I'm only concerned about 4. That's the only number in the problem. Okay? Is it an open dot or an open circle, or is it filled in? What is it?
Open.
It's open because it's just less than, right? Okay? So I would make a clear open circle around that. Okay? Then I want numbers smaller than x, or smaller than 4, excuse me. So smaller numbers are to the right, or excuse me, to the left, the other right. Okay? So that's one way of doing it. Another way of doing it would look like that. Okay? Those mean the same thing. Either you put your dot on the line or you put your dot above the line, but either way your arrow goes above the line. Okay? And if this were equal to, then I would just have 2 filled in circles there. Okay? What I don't want is that. Because you're going to do it probably in one color. If you're a multiple color type person, I love you. Okay? But more than likely you're going to do it probably just in pencil. And that's fine. I got no problem with that. But I drew those blue ones, I drew there in red. Can you tell it? I can't. And I'm the one that drew it. Okay? So it has to be distinct. It has to be what we saw, or what easily seen to somebody else. Okay? If you're questioning, ask somebody else. Can you tell what this means? And I'll say, yep. Okay? Or ask your neighbor, or ask your brother or your sister, or your mom or your dad, or your boyfriend or your girlfriend, or some random person on the street. Okay? Right? But it's got to be clear. Okay? Red, not clear. Blue, clear as the sun. Okay? Okay? Now, to get to this point, to get to the graphs, we're going to have to do some solving. We're going to have to solve some inequalities. The nice thing about solving inequalities is that it's just like solving equalities. Okay? Whatever we do on one side, we got to do it to the other. Okay? If I want to move something, I got to do the inverse. Right? All that stuff. Except there's one extra condition. And that extra condition is if I multiply or divide by a negative number, the inequality has to flip around. Okay? So if I'm dealing with something and it's a less than problem, I multiply or divide by a negative number, now it becomes a greater than problem. inequality has to flip. That's a 3 exclamation point, totes importante. Okay? Some might even say hashtag know this. Okay? Right? Put that one in long-term memory. Okay? Let's try something. Let's do this. Yeah, buddy. All right? So, first one. Okay, if I were solving this one, I would first get my letters, my variables on one side, my numbers on the other side. And just like with the equations, it doesn't matter which side I put that stuff on. Okay? Because I got a brain in between my ears that's going to allow me to make the graph based off of that. Okay? Right? So then I'm going to divide. In this case, I want to get my x by itself, so I'm going to divide by 4. Does my sign have to flip? Why not?
It's not negative.
What's not negative?
4.
The 4 that I'm dividing by, right? Okay? I only flip my sign if I multiply or divide by a negative number. Here I'm dividing by positive 4. Sign doesn't need to flip. Okay? So that stays x is greater than or equal to 24 divided by 4 is 6. So I got x is greater than or equal to 6. Everybody agree with that? Okay. That is the solve part. Okay. So the solve part, I write out my solve inequality. The graph part, now I take that solved inequality. The only number that I'm concerned about is 6. Okay? And I make my graph based off of that. So, I have an open or a closed dot at 6. It's closed because it's got an equal part to it. So I fill that bad boy in. Okay? Now, logic tells me that this solved statement says I want all numbers bigger than or equal to 6. On a number line, where are the bigger numbers?
Right.
To the right. Smaller numbers left, bigger numbers right. So I want numbers bigger than 6, so my graph is going to go to the right. Okay? And that is the graph part. Both are required in this problem because it said solve and graph. So I need to give both in my answer. Okay? What I would like you to do now is I would like you to do both B and C. Now I don't know if it's recording or not. Alright, it's going up. That means it's recording. Learn it. See again. Windows guy now suddenly on a Mac. I tell you, all this stuff's going on. Alright. Alright, first one. Subtract 20. Agree? That gives me 3x is less than negative 12. Divide by 3. Does my sign, or does my inequality, need to flip? No, because I'm dividing by a positive number. Even though I'm dividing into a negative number, I'm not dividing by a negative number, so it does not need to flip. So this stays x is less than negative 4. On a number line, the only number that I'm concerned about is -4. Open dot. I want numbers smaller than -4. So smaller numbers are to the left. Agree? Okay. Next one. 8 minus x is greater than 17. I would first subtract 8. That gives me -x is greater than 9. Then I would divide by -1. That gives me, whoa, tap the brakes. What am I doing? Flipping the symbol, yep. So this becomes x is now greater than -9. My symbol there needed a flipping because I am dividing by a negative number. Okay. So then my number that I'm concerned about is -9. Open or closed? Open. Left or right? I want numbers bigger or smaller than -9? Logically, what does this say right there?
It says that x is less than negative.
So I want numbers smaller or bigger than -9? Smaller. Which way is smaller numbers? To the left. Okay. Side note, for these you don't necessarily have to, but like when we're solving equations and you've got a lot of work shown and then at the end you got your answer, circle your answer or box your answer or star your answer, set your answer apart. Okay? I set my answers apart with this pinkish dashed line thing. Okay? Let's do E and F off of this. E and F off of this one. All right, so first on E, I would subtract 2. That gives me 10 is less than or equal to -4x. Then I would divide by -4. That flips my sign. Gives me x over here. 10 over -4. 4 doesn't go into 10, okay, but 2 does, right? And 2 goes into 5. So this would be -5 halves. Okay? On a number line, I can put down negative, that's a really bad 5, -5 halves. Just like that. I don't have to convert it into a decimal. We're a fraction class. We can leave stuff in fraction form. Okay? Open or closed dot. Closed dot here. Okay? Logically, what is that saying?
Could be equal to -5/2.
Okay? But I want it numbers that are
Greater, less than.
smaller or bigger? Smaller. I want smaller numbers because remember the alligator or the crocodile eats the bigger number. So -5 halves is the biggest number that it can be. I want everything else smaller than that, and smaller numbers are to the left. Okay. On F, first I would distribute that 5 into there. So that gives me 5x minus 6 is less than or equal to 5x plus 5. Then I would subtract 5x. Then I would add 6 to both sides. And that gives me 0 is less than or equal to positive 11. Okay. What can you tell me about 0 is less than or equal to positive 11? What do you mean it doesn't work? Does it have to be the same number, though? Okay, variables are gone. Okay, so what happened earlier this week or last week when the variables went away? No solution or all real numbers, infinite solutions case, right? Okay, what was the difference between those two?
All real numbers is like if they're both variables, and no solution is when they're just two different ones. Real numbers.
Close. I know what you're saying, but I think we can say it a little cleaner. All real numbers happens when it's I said it in class last week. When it's all real numbers happens when it's we know the variables are gone, right? What about the statement that's left? All real numbers happens when it's a false statement? That's what I'm asking that. I'm asking that. Is that what you're saying?
Yes.
Okay, I don't like it.
Just tell us what you said last week.
Look back in your notes. Why don't you do that? Here's a crazy idea. Turn back. Look back in your notes. All real numbers happens when it's something. No solution happens when it's something. I think it was even on a note sheet, wasn't it? Wasn't it one of the, it was a station, I think. It was on a note sheet,
Yeah, it was definitely one of the stations.
Yes.
I don't think it was.
All real numbers happens in something. No solution happens in something. Well, right? Okay, so if all real numbers happens when both sides are equal, that makes that a 7 equals 7. 15 equals 15. 92 equals 92. What are all those? Those are all...
Why is this like rocket science?
It's not.
The same.
I get that they're all real numbers. Pi equals pi. Square root of 3 equals the square root of 3. Those are all... It's a 4-letter word that starts with T and ends with ru.
True.
Those are all true statements.
That's
No, it's not. Okay? Those are all true factual statements, right? Okay? It's no solution when what? When they don't equal each other. 7 equals negative 82.
It's a false statement.
It's a false statement, okay? So it's all real numbers if it's a true statement. And it's no solution if it's a false statement. Okay? So, back to 0 is less than 11, or 0 is less than or equal to 11. Is that a true statement or a false statement? True or false?
0 is less than 11.
Is 0 less than 11?
Yes.
So is that true or false?
That's true.
That's true. Okay? So what is the answer here?
Is it all real?
It's all real numbers because it's a true statement without any variables. Okay? Now, the number line for that, we've got two numbers to deal with here. The number line is going to actually be just all the way across. It's just going to be a stripe. Now, a little side note, had this been a false statement, had this been 11 is less than or equal to 0, that's a false statement, right? Then it would be no solution. And my number line would look just like that. It wouldn't have an arrow on it. Okay? All right? Now, let's talk compound inequalities. This first kind of compound inequalities, well, first off, compound inequalities means that there's going to be more than one going on. Okay? Excuse me. We'll probably limit it to 2 in terms of these linear type ones. When we get into systems, then we'll go into more. Okay? But so this first one is an AND statement. Okay? In an AND statement, both parts need to be true. How you're going to go about this is you are going to work all the parts at the same time. So if you add something in the middle, you're going to add it on the outsides at the same time too. Okay? If you multiply or divide by a number in the middle, you're going to multiply or divide a number on the left and the right side all at the same time. Your graph for these is a handle. Meaning, okay, you're going to have two numbers. In this case, it's -4 and +8. Okay? We're closed at -4. We're open at 8. And we need to be greater than -4, which is to the right from -4. but we need to be less than 8, which is to the left of 8. So it's in between those two numbers. Okay? And they both have to be true there, and that's the only spot where both are true. In an or statement, you will see the word or. Okay, you will see it in between the two inequalities. Here, only one part needs to be true. Here, you are going to work the parts separately. Your graph is going to be a rowboat. Okay. So we're at 3 and 7. I want numbers less than 3, so I'm going to make one or of the rowboat, and I want greater than 7. There's the other or of the rowboat. Okay. Let's do this. I'm running low on time, so I'm going to go a little quickly on this. Subtracting 5 in the middle to get rid of that, which means I have to subtract 5 on both left and right sides. That gives me negative 15 is less than 3x is less than 3. I'm going to divide then by 3 in all of my parts. What if I divide by a negative sign or by a negative number? Both of them have to switch. Okay? Both inequalities flip if we multiply or divide by a negative number. So that's going to be negative 5 less than x less than 1. The two numbers that I'm dealing with are negative 5 and positive 1. Both open. Since it's an and, it's going to be in between. These ones I'm going to work separate. Subtract 3 on the other one. Divide by 4. So I get that. Negative 3. Positive 1. At negative 3, I'm a closed dot. I want numbers smaller than that. At positive 1, I'm a closed dot. And I want numbers bigger than that. Okay. Homework for this evening is that. Okay. It will be due on Monday, which is also the day of your test.